Welcome to another presentation in our best practice series for the VersaPass platform. My name is Evelyn and I'm one of the application engineers here at Memjet. Today we're going to cover addressing common print quality issues. The objective of this webinar is to provide you with some examples and some tools, and this will help you identify and remedy common print quality issues using our best practices. This should help you minimize your end-user downtime related to print quality issues. Today we're going to cover diagnostic tools, how to identify and resolve print quality issues, and reducing those interventions. So let's get started. Like the tires on your car, a VersaPass printhead is a consumable and it requires replacement when it wears out. The length of a tire's useful life is often dependent on how it's used and how it's cared for, as well as the external conditions that the tire is exposed to. The same is true of your printhead. We may not be able to change the duty cycle or the content of the application, but we do have quite a few knobs to defend against some of the external factors that impact print quality. But first, let's take a look at how a printhead actually wears out.
This example will apply to applications that rely more on text, such as mailing and shipping applications. But generally speaking, almost all printouts will have some text. In the beginning of a printhead's life, the dot placement is very good. Here you can see the text is sharp and clear. As well, the corresponding nozzle pattern shows good dot placement. As the printhead is used, the nozzle wears, and the dot placement becomes less accurate, resulting in print artifacts. In this example, we see little tails at the trailing edge of the letters. Looking at the corresponding nozzle pattern, we see the dot placement is becoming less accurate, and we actually refer to this as misdirection. As the printhead gets into its end-of-life phase, the print artifact is more severe. The tails are more obvious and more frequent. The corresponding nozzle pattern from the printhead displays severe misdirection as well. At this point, the printhead needs to be replaced. Wear out and misdirection look a little different for applications that use area fills. In this case, usage in nozzle wear will display as fine streaks and density shifts across the printhead. In this example, the black channel is tested, so we see fine streaks and uneven density in the black channels across the page. With equivalent usage, other colors would show a similar effect. So I want to make a couple of quick points. When a printhead reaches its end of life, you're going to see misdirection, fine streaks, and density shift. These print quality issues are not recoverable. And the second point to consider is that your application's print quality threshold will guide you on how much misdirection or fine streaks are tolerable before a printhead needs to be replaced. You may be thinking, those images look nothing like what's really being printed by the customer, and you'd be right. The examples we've seen so far were diagnostics. They were designed to highlight the wearer-out signatures. They're designed to accent a specific area of interest. And end customers don't print color bars. Customers have much more diverse and complex artwork, and this can add to the challenge of diagnosing print quality issues. To bridge the customer images to the diagnostic images, Memjet has developed a printhead test page. This page is embedded in firmware, so by default already available to your field install base. Check with your supplier, but this may also have a detail page that prints out usage information for the printhead. So let's take a look at what it has to offer. Memjet has packed in the most common attributes found in all printed images: line art, color fill, and text. Top left justified is a hollow fiducial, so you will always know the page orientation in relation to your printhead. There are nozzle patterns, and these are great for assessing dot placement, overall nozzle health, wear, and random contamination. Line art at the top of the page. These are useful to determine nozzle wear, misdirection, and dehydration. Note the nozzle wear out and misdirection in the black lines. Color bars. These are akin to color fill areas. They're useful to display streaks, dehydration, and in this case, an example of black misdirection into the magenta channel in an area of localized wear out. Next we have text. There are 4 sizes of font, and we've already reviewed the tails that can happen due to wear out misdirection. Here we have the appearance of double strike in the black, and that's a sign of severe wear out, and in this case a very localized area. This is a tool you'll want to add to your toolbox if you have not already done so. It works well as a checkup print once you've completed a field repair or maintenance. It works well for a press operator's startup routine to check the printhead health. And best of all, it's great for most print quality diagnostics. We've looked at some visual indications of wear out and explored some of the uses of the printhead test page and how that can be used to isolate and identify print quality issues. Let's take a look at some of the common print quality issues and see how we can apply this tool. Streaks are by far the most common reported print quality issue. Just as the elements dirty up your vehicle, the most common root cause for streaks are external mechanisms. For example, dust, debris, aerosol, moisture, and air. And while most streaks in the VersaPass desktop platform are similar in appearance, they have a diverse range of causes. The good news is that there's quite a few adjustments built into the system to address these issues.
External contaminants. The two most common forms of contaminants that make it onto the printhead nozzles are environmental debris and paper dust. Even in applications using craft liners and synthetics, they are prone to debris and shedding through the friction in the media handling path. These particulates are transported through the media handling system and latch onto the printhead during the print job. And if not cleaned, they will block the nozzles and result in streaks.
Streaks from contaminants may also be called white streaks or transient streaks. These streaks have several common visual characteristics. They are usually less than 3 millimeters in width. They tend to move around in location on the printhead from print to print, and they extend through multiple color planes. Generally, transient streaks can be resolved with a printhead wipe. Our best practices for avoiding streaks from contaminant is to address it preemptively by making small adjustments to the maintenance routines. For example, increase the mid-job maintenance frequency intervals. Change out the microfiber roller as recommended. Keep the print zone clean and free of debris. Add a media cleaner to the system if you have a particular media that's causing issues. If the system's not fitted with this device, consult your support team for additional information. The next type of streaks we're going to talk about are streaks from aerosol and condensation. These streaks are typically parabolic shaped, and sometimes they're called drips or puddles. They can vary in severity as seen from left to right. These streaks develop as droplets of aerosol and condensation accumulate on or near the nozzles during printing. This occludes a localized group of nozzles, and once that droplet gains enough volume, it drips off the nozzle face and onto the output. Higher density printing correlates to higher levels of aerosol and condensation droplets. This, in combination with high humidity level, will represent the worst case scenario for the issue to occur. Other factors that impact condensation and potentially drips will be the length of the job and the mid-job frequency that is used for that job. So best practices to avoid condensation and drips are to increase your mid-job maintenance frequency intervals, especially in high-density printing or high humidity environments. Another option is to reduce your ink limits. Some applications offer tools to do this within the driver of the RIP. It can also be accomplished in profile adjustment. And lastly, you can include aerosol extraction in the system. If your system is not fitted with the device, consult your support team for additional information. The next type of streaks we're going to talk about are air-related. This is where air is trapped inside the printhead and makes its way onto the printed output. Air streaks are identified by the irregular or flame-like shape, and they are typically confined to a single color plane. The examples from left to right display increasing severity. Typically, you will experience this after a new printhead insertion and priming sequence. The most common reason this occurs is incorrect printhead storage orientation. When the printhead leaves our factory, it has a fluid inside, and this keeps the back channels wetted and maintains a meniscus for the nozzles. These are key elements to a successful printhead prime. When the printhead is stored either nozzle up or if the box is in an upright position, the fluid drains away from its intended position. The printhead dries out and priming is less effective. Recovery for this is usually a second priming sequence. A secondary cause of air in the printhead is an air leak in the system. For example, if air streaks suddenly crop up and don't subside, it's worth investigating to figure out where the air is getting into the system. Next to the printhead has a gasket, and this can become worn, allowing air to ingress into the system. This is a replaceable part, and we recommend consulting your support team for additional information on repairs. We have covered streaks that occur from contamination, from condensation and aerosol, and from air. The key takeaway here is to recognize the symptoms and apply the appropriate recovery process. If we just look at a quick fix to the problem and instruct users to use a heavy recovery, it's about the equivalent of putting out a trash can fire with a fire hose. And what's problematic about this approach is that it costs time and it costs maintenance dollars, and end users become frustrated. As you have seen, most of these print quality issues can be resolved with some simple steps once they've been identified correctly. Using best practice guidelines, the issues can be mitigated for the longer term, which will result in lower interventions and improved print quality. So when you're troubleshooting these types of issues, take into account your end user's overall system, environment, and goals. And then you can help them to make the adjustments necessary to support their application. The next category of print quality issues is dehydration related. Dehydration can be exacerbated by the environment. For example, if you were driving in the winter weather, you'd likely use a heater. If you were driving in the desert, you'd have the air conditioning turned on to maintain comfort level. Well, the printhead also has a preferred comfort level, and we call this the operating range specification. For optimal results, the printhead needs to be used within the operating specifications of 15 to 30 C. Not only do you have the operating temperature level to consider, but in relation to dehydration, we also have to consider the humidity range specification. Temperature has an obvious seasonal or regional effect, and it's easy to see in these images. But what may not be as obvious is that these seasonal or regional shifts also have the commonality of low humidity levels. And low humidity levels are the zone that influence dehydration. Fortunately, we have a couple knobs built into the system to offset dehydration. Simply put, dehydration causes water loss, which in turn increases the viscosity of the ink and results in print artifacts. You always hear the term, keep the printhead hydrated or keep the nozzles hydrated. But actually the goal is to keep the printhead filled with non-dehydrated ink. Let's take a moment to go through the different levels of dehydration and the effect that they have on print quality. Now, when your ink is fully hydrated, your ejection is normal and you have no visible artifacts. When you have a slight level of dehydration, you have reduced water content in the ink, and this causes increased diluting, which results in intensified colors. If you have a moderate level of dehydration, again, increased viscosity, but now it has poor nozzle directionality, and that in turn causes misting and directionality artifacts. With severe dehydration, we actually get to a point where we can't eject from the nozzle, and you get voids in printing. Now I'd like to show you how these effects display on printed output. Startup dehydration has intensified color. These appear as parabolic shapes spaced about 1.25 millimeter apart. This issue dissipates down the page as the nozzles are refilled with fresh ink. Moderate dehydration displays as the startup directionality issue. Both the slight and the moderate dehydration tend to print through and recover, but this compromises your first printout. Best practice recommendations to avoid dehydration are keep the printhead capped when it's not in use. For example, you may have the option to leave the printhead uncapped during a pause, but keep in mind dehydration of nominal humidity can start to occur in as little as 7 to 10 seconds. So it's not recommended to operate with the printhead uncapped except during printing. Another best practice, keep the printer powered on. This allows idle time maintenance to keep the ink circulating in the system and freshens the ink in the nozzles so it doesn't become dehydrated. Operate within the environmental specifications. And finally, use adequate keep wet spit levels and increase those KWS levels in higher temperatures or lower humidity environments. The visual symptoms for dehydration within a job are the same as what we've previously viewed. There are two common use cases sensitive to this. Dehydration occurs within a job when the content changes and fires nozzles that previously were non-fired, as you see in this example. Another common use case that lends to dehydration within a job can occur with low content printing and inadequate keep wet settings. The mechanism in both of these cases are the same. The non-firing nozzles dry out over time and lose their print-ready state when there is not enough on-page or interpage KWS. High temperature and low humidity environmental conditions exacerbate the issue. You can avoid this by operating within the environmental specifications. Increase mid-job servicing with longer jobs. Use adequate levels of KWS and increase the KWS level in drier environments. There is one last form of dehydration to go over, a dehydrated printhead. In this example, the printhead has been stored external to the unit after use, or in a printer that's been powered off for a prolonged period of time. The defect signature is lines spaced about 1.25 millimeters apart. Not only are the nozzles full of dehydrated ink, but so is the supply channel that fills the nozzles. Now, over time, ink can be rehydrated with fresh ink, so this typically takes multiple maintenance cycles to clear. And in some cases, depending on the severity, the printhead may not recover. You can avoid printhead dehydration by not storing the printhead outside of the unit after use. But there are occasions when we absolutely must do this. So let's follow these steps. Wipe it clean with DI water and a lint-free cloth. Place the printhead in the orange protective cap. Seal it in a Ziploc bag with a damp cloth, nozzles facing downward. I want to wrap up today and leave you with some final thoughts and troubleshooting tips. Your printer is a complex ecosystem with various subsystems and the external and environmental factors, all interacting to produce printed output. Your print quality is the net result of these subsystems and external factors performing well together. One final printhead troubleshooting tip. It's a pretty normal response to assume the printhead is the culprit and change it out, but that's a fairly expensive fix. So the next time you have a print quality issue that you can't quickly resolve, try a less expensive approach. Take the printhead to a second unit. If the issue follows the printhead, then likely it's a printhead issue and you need to pursue that avenue. But if the issue doesn't follow the printhead, investigate those external factors and subsystems. And if you don't have a second unit available, be sure and print out the printhead test page and contact your technical support team for additional help. I want to thank you for your time and attention today. I'd greatly appreciate your feedback in the quick survey at the links shown above. Take care.